Is everybody interested in actually listening to EME? Raise your hand. We have 1, 2, 3. All right. Most of the time, actually, EME is not a topic that people would like to discuss in terms of small cell and DAS, because that's really an afterthought, if you think about it. But before I actually go to my presentation, let me introduce our company first. So SiteSafe actually has multiple services that we actually provide for the carriers. A lot of people don't know that on the background, on the regulatory compliance side, we actually work with all the major carriers. And we do electromagnetic emission analysis, non-ionizing radiation studies. We do intermodulations, AMD tuning. We do FAA work, and we do RF safety awareness, and at the same time, spectrum watch. These are services that on the background are actually required when you're building a network, whether it's macro or whether it's small cell. In some cases, even ODAS nodes on a rooftop. And we do this for all the carriers. Now, before I go into my main talk, I would like to really look at what the FCC regulations are really in terms of EME. And really, there's two levels that the FCC has actually regulated. And one of them is general population, which is uncontrolled level. And they want to make sure that the levels of RF or radiation within the general public has to comply with FCC regulations. The other one is what they call the uncontrolled level, or should I say the controlled level, the occupational level, which is really the levels where you can actually work at, and it's not for general public. And typically, the uncontrolled levels are 5 times more conservative than the occupational or controlled level. Now, most DAS are deployed near public areas. So typically, you have to do analysis based on the general public criteria. This chart actually represents the regulation. So definitely, it's dependent on frequency. And again, the difference between occupational and general population is such that general population is a lot more stringent rather than the controlled environments. Okay, so FCC, again, they want to make sure that there's multiple levels of compliance, and one of them can be theoretical calculations, which we actually do with our tools. And you can also do measurements, or you can actually do both. These are services that we actually provide for all the carriers. Now, if the RF levels on the ground areas if the exposure limits are actually above the FCC regulations, then there's a lot of things that can be done. And one of them can either be to increase the height, or the other one is to lower power. But all of these can actually be looked at and analyzed. Here's an example for a situation where you would need to put signs on a pole. This is actually a simulation of a canister antenna at 37.1 feet, for example, above the ground. And this prediction here is not RF prediction in terms of coverage, but this is actually compliance prediction. So the different colors would actually show you what the different compliance levels you're in. Okay, now with that in mind, let's look at DAS and small cell and what are the considerations that are typically done. So most of the time, we look into coverage, capacity, and the technology. Those are the 3 main things that people look at. EME or RF compliance is typically not looked at because the thought process is that it is low power, therefore, most probably it's going to comply. And if you look at IB wave modeling, and when they run compliance in IB wave, you would actually see that the compliance levels are like a couple of inches, sometimes 6 inches at most. So if that would be the case, then it's not really needed to actually look at compliance. However, there are a couple of concerns that we actually have. And again, this is based on some of the studies that we've actually seen from our customers. One of the things that we have seen is that some of the IB wave designs do not have all the RF sources connected. What do I mean by that? Because there's limited time in doing designs, typically what they do is they make a representative configuration of the design. So it's not a complete design. The other thing that we've actually seen is that some systems are actually deployed MIMO, but the design is only showing SISO. So again, the problem with that is you're not totally depicting what is required for RF compliance. The other thing too is some of the neutral host designs are actually designed only based on the lead carrier. So they are not considering all of the carriers in the system. All of these actually contribute to the, shall we say, error in calculations in terms of the EME compliance. Because the regulations or the FCC rules say that all of the RF sources within a given area should actually be measured or should be predicted so that then the composite impact is determined for RF compliance and not just for individuals or individual carriers. These colors would represent basically the predictions, just so when I go through the different slides, you'll actually see what I mean. So if it's gray, it means that you're below the general population MPE levels. If you're green, you are within the general population. If you're blue, you are below the occupational, but you're above the general public. So which means you're failing general public. If you're yellow, it means you're above occupational, and if it's red, it means you're 10 times above the occupational. So really, in terms of general public, every time you see a blue, a yellow, and a red, it means you're already failing general public. And I'll go through a couple of use cases so that then you understand the impact of MPE in terms of the systems that are actually being deployed. All right. This is an example of a 5-watt SISO with multiple carriers. So if you look at the compliance prediction, it's very small, right? And in reality, you only need a warning sign. And again, you don't even need one below. You just need it close to the antenna for people that are actually climbing the tower to understand that, yep, there's an RF signal over here that needs to be considered when you're working close to the antennas. If you do a MIMO system, you're basically doubling the power going into the antenna. And if you look at the compliance predictions, it also changes. Now, granted, it is still passing. You need to understand this because what happens if you actually put in a 20-watt system instead of actually a 5-watt? That changes quite a bit. And so the compliance requirements would then change as well. This is an example of when they actually use a remote radio head, meaning it's really more of a small cell deployment. That would mean that instead of actually having a DAS node, a 5-watt DAS node, you may actually have 5 watts from each of the different bands and each of the different carriers. So if you compare this to the other one, the previous slide, you see how like it's not as bad versus this. You can see that the compliance now is actually changing. Now, if you want it MIMO, now you actually see that instead of it becoming just the blue, now it's actually at the yellow level. So there is an impact into doing an outdoor coverage solution, whether it's shared environment DAS versus a remote radio head individual units and the compliance requirements. So that is something that really needs to be looked into when you're designing small cells, because it does impact the way your regulatory compliance is performed. Now, this is assuming a 30-foot. Is that like 30-foot? Yep. Now, what happens if this actually goes down a little bit? And then what happens if this one actually has a down tilt? So this could really impact your design and your system. Here's an example where you're doing now a 20-watt or a 40-watt DAS. And this is just a DAS. See the difference between the 5-watt, the 20-watt, and the 40-watt DAS. There's significant changes to the way, and again, all of this is considering a canister antenna as a simulation. Again, it doesn't impact really general public underneath, but it does impact people that would be able to access the antennas. Like if this was a power pole and somebody needs to work on the power pole, you need to consider the fact that at this level, you may actually want to turn off the radios for people to actually work above, because this is very close. You need to be like within 2 feet or 4 feet of the antenna to be compliant. And you can't really work 4 feet away from the pole if you're trying to work on the power lines, right? Here is an example for a DAS environment. Again, you're starting to get closer to the people. Now let me ask you guys this. Have you ever seen a warning sign close to an antenna in a DAS? You haven't, most probably. And most probably that's never going to happen. But in reality, to be compliant, there is supposed to be a sign close to the antenna that would actually say, hey, I have an antenna over here, and there is a possibility that if you're changing a light close to these, within 2 feet or 3 feet within the antenna, that you may want to turn off that antenna. But nobody actually likes to consider that, right? Now what happens, for example, if you have a 5-watt MIMO multi-carrier on a DAS? Again, it's the same thing. You have to consider the fact that the signals are now actually getting even stronger. Here's an example of a stadium using remote radio heads or small cell. And as you can see, it is possible that you can be out of compliance. This is worst case scenario, but I've actually seen some deployments where they have an antenna pointing here and antenna pointing to the other side. So again, the challenge here is that if you don't consider this on your design for the first hand, you might be designing thinking that it's passing, but by the time you make the adjustments to your design, because of the power levels, you may not have the correct design. You may actually have to lower your power to actually comply. And when you lower your power to comply, guess what? Your signer levels might not be at the right levels as well. If you're trying to overcome macro in a stadium environment, you may not have enough RF to actually overcome the macro as well. So again, in most cases, these is not considered, but we've seen some of the deployments out there, and when we started doing the analysis, we actually saw that there are cases where this actually fails. And nobody's actually aware of that, because nobody's actually looking at it. Now, what's the impact really on this? You would just feel hot. By the time you get out of underneath the antenna, you would be fine. The problem is, if you get too much exposure, if you're there for hours sitting underneath the antenna, that becomes a real problem. So again, it is important that when you're doing your design, you have to consider RF compliance, because there is a possibility that you would fail. This scenario is typical when they're actually doing what they call CRAN deployments or remote radio head deployments, where all the carriers would have their own remotes per band. And again, as I've said, we've seen that in the past, and we have to recommend some changes into their configuration. And again, if the antennas are actually lower, because I've seen some stadiums with lower heights, this can actually even pose us even a greater problem than what I have depicted over here. This is an example where on a racetrack, you can actually have poles, and sometimes they limit the height of the pole. And the reason why they limit the height of the pole is there's a visual impact when you're at the stands to actually see the race. You want to see the race all around, right? So you have to limit the height of the poles. But they also want to cover the parking lots that are inside the racetrack. And at times, they would actually require a remote radio head design. And in some instances, there are RVs parked close to where the pole is. And sometimes they actually go and sit on the top of the RVs. Have you ever seen those in NASCAR? Who are NASCAR race fans over here? No? Nobody? I've built a couple of these actually in my life. I've built a couple of racetracks in my life, and you would see that the RVs are like parking lots in the NASCAR race. And a lot of people are actually on the top of their RVs watching the race. So in this example, there's actually a guy over here, and there's an antenna over here shooting down because they want to limit the coverage so that then they can have more capacity. And what's happening is he's actually basically being fried because he's very close to the antenna. This is only 12 feet away from the antenna. And you might say, 12 feet, that's actually too close for an RV and a pole to be close together, right? But in reality, because the space is so limited in a racetrack, there would be an instance where an RV would be very close to the pole. And so you have to consider this as well. So bottom line, when you're actually looking at your design, it is an afterthought, again, to look at EME levels. But in reality, you should really be looking at EME levels so that then your design will actually pass RF compliance. Now, what are the different signs that are actually being provided? There's the notice sign, there's the caution sign. Again, these are known by the carriers, and these are the ones that they actually want to be posted. There's also a warning sign, but there's also some information that's actually being provided just in case you need to turn off the towers or the antennas within the small cell or the DAS. This is an example for Verizon. There's another example for Sprint, AT&T, or all the other carriers will actually have it. This is an example of an outdoor small cell. They actually have multiple sectors. I understand it's on a roof. We do this, for example, for Walmarts. We have deployed a couple of these where it's a small cell. They actually put in 3 sectors. It's low level, right? But you see, we still put signs close to the antenna. And again, the reason for that is if somebody's working on this air conditioning unit, right, they need to know that there is RF that's actually close to the antenna. I mean, to the areas where they're going to work. Okay? Now, this is an example for a small cell. This is an example for a typical macro site. And even a typical macro site, as you can see, this is not even in front of an antenna, but we still actually put the warning sign just to make sure that everybody's actually aware that there is RF coming out of these antennas. And a while ago, one of the presenters said that there is back signal coming out of these antennas, and that's the reason why you want to make sure that you actually have these signs as well. Here's another example where we actually have signs on the back of the antennas. Here's an example of a canister antenna, small cell deployment. And as you can see, there is a sign over here that actually shows you that there is RF coming out of the antenna. So that then when somebody works on this power pole, especially where the, for example, above here, you'll see that they need to turn off the antenna before they can actually work on the actual pole. So in conclusion then, although in most cases RF compliance passes, it is still critical for carriers, third-party operators to ensure that they actually look at the RF compliance of the systems that they're actually deploying. Because if they don't consider that, it is possible that you'll actually fail your FCC compliance. And typically for DAS and for DAS, it's not as bad because you're sharing the RF, and so it diminishes in terms of per carrier, and the max is really just 5 watts, for example. But when it comes remote radio head or small cell, where each of the carriers will have their own small cells, what's going to happen is the cumulative impact from each of the other carriers. So just imagine this. If you have, let's just say 4 carriers. The first carrier says Verizon, you already have 4 remote radio heads that you're going to deploy for one sector at 5 watts each. So that's already 20 watts just for that. And then you add in AT&T, that's another 40 watts. So you're now up to 80 watts. And then you still add in Sprint, and then you add in T-Mobile. All of a sudden, your 5 watts is not really 5 watts anymore. It can be in the 100 plus watts, and you're not even considering the antennas yet. And the antennas, if it's a 10 dB gain antenna, it means that you're multiplying your gain, your output by a factor of 10. So again, special considerations need to be looked at, especially if you're actually doing remote radio heads. So when you're actually doing designs, small cell DAS, especially on large venues, again, it is better that you consider the fact that the FCC regulations dictate that it's the cumulative impact of all the RF sources in a given antenna or a given area that needs to be considered, and not just the individual ones. Any questions?
Who's monitoring? It could be out of FCC regulations. Who's monitoring that?
Good question. So what we do for the carriers is that, depending on the carrier, there is a program that we have with the carriers that such that if they modify their systems, we actually go and do the study for them. And therefore, we can either change the signs or provide what we call barriers to make sure that they comply. The other thing too is before they even turn up the sites, we can actually do modeling for them to determine whether they are compliant or not. And if they're not compliant, we can give them a little bit of recommendation as to the power levels that they can use or a mitigation technique so that then they can become compliant. Any other questions? No questions? Thank you.
Great job. Thank you so much.
All right.